Mr. Cloud for 5 minutes.
Thank you. This is an exciting topic. I'm really happy that you all are here to talk about this important issue. The world's demand for energy is growing. I have always believed that the solution to the challenges we face is advancements in technology rather than us all retreating from the industrial age. So it's exciting to see the developments that are happening. Mr. Kennedy, I'm really amazed, first of all, to hear that a project was done on time and on budget. And so if you could, first of all, give us a manual on that, that would be applicable across a number of spheres. But in all seriousness, there was a project, I think in Kemper County, Mississippi, where the government invested almost $400 million that ended up being wasted. So what was the difference in the success that happened at Petronova? How can we be effective in investing the taxpayer dollars to get the desired results?
Yeah, sure. And they had a totally different technology. So what was successful for us? Number one is, and like I mentioned, it's a scale up of a demonstration project. So there was some history that the technology actually works. 90% of our engineering was done prior to starting construction. So there was not a lot of scope changes. We had phenomenal partners. We basically formed a consortium with our technology provider and our contractor and did a single EPC contract. So they worked together on meeting the needs that we had in our turnkey project. So a lot of those, I think, were very helpful to get us to where we got to.
And Mr. Krishnamurthy, hopefully I said that right. I really appreciated a lot of how you phrased this in the need to have research that gets this to a market-based approach. I think as far as moving this into the future, that's the best approach as opposed to a heavy hand of regulatory environment. And of course, we'll need some light touch there probably, but in the sense of what technologies, what research areas need to be done, what are the areas we need to focus on that will get this to market viability in the sense, and maybe all of you all can lead into this a bit.
Sure. We believe that a large part of this is on the capture side, and we've got to look at point source capture as being the first and foremost place where we can do this work. You heard from Petronova, they've done some very interesting things. The other story in the Houston area, which has got another very large natural gas-based power plant that's developed a new technology that is ready for the commercial world, is something that you'll hear from Net Power. They've done some pretty amazing work. That's the kind of technology that needs to be scaled up.
Repeat their name again.
Net Power. They are in Pasadena, Texas, and they've done some. They've demonstrated at 50 megawatts what they can do to capture CO2. They need to scale up. We need to find ways to get that technology ready for the marketplace. Likewise, I believe the distributed sources are something that we've got to look at. We've got abundant renewable electricity available that is not being utilized. How do we get that to be utilized and produce CO2 at places where it can be used? Right now, there is more demand for CO2 in the state of Texas than available piped CO2.
Okay.
The big challenge is pipeline. A pipeline, and that's something that can be addressed by a light touch of regulation. Change CO2 from being a waste product to being an accretive material that can create economic value.
That was going to be my next question on if the infrastructure existed or what needs there were in helping us to make it to that.
Yes, going to a common carrier pipeline will relieve enormous challenges today in the CO2 market. And that will mean you get to see a lot more of these planned activities being done at scale. And the more we can do things at scale, we can make this cheaper. Yes, we're doing a lot of things in the science and engineering world that it will be disruptive, but that's 5, 10, 15 years out. We need things to happen now to make it viable for the future. Thank you.
Now, one of the great successes I see here is that in this case, the investment went to technologies that went to practical applications. Do y'all have any suggestions for, because a lot of times we'll invest in research, we'll have these breakthroughs, they make it to the journals, but they don't make it to to practical application, do y'all have any suggestions for how we can be more effective nationwide at getting the research dollars that produce the breakthroughs that actually make it to the sphere of application?
Yeah, you're absolutely right. There's a huge valley of death between fundamental discovery of some new possible technology and demonstration. And, you know, one thing that does try to address that is ARPA-E. And I think it's something we need a lot more of. There's a disconnect between the scientists doing the fundamental research and engineers who know how to build a practical device. We need to bridge that gap with funding, get those scientists and engineers together.